Hello students, continuing with the topic superconductors for BTech first year engineering physics syllabus. Today's heading comprises of high temperature superconductors and applications of superconductors along with their properties. High temperature superconductors, HTS. That means they are abbreviated as HTS. They are operatively defined as materials that behave as superconductors at temperatures above 77 Kelvin. The boiling point of liquid nitrogen, one of the simplest coolants in cryogenics. The high temperature superconductors are neither metals nor intermetallic compounds, but they are oxides. Their unit cells are complicated ones. The unit cell of a new superconductor contains one atom of a rare earth metal such as yttrium, two barium atoms, three copper atoms, and seven oxygen atoms. So yttrium, barium, and copper. So you can see the subscript here as 1, 2, 3. So the number of atoms of each metal element in the superconductor is giving the name 1, 2, 3 to these compounds. And the most common example is of yttrium, barium, copper superconductor. And this is a high temperature superconductor with a very complex diagram of the atomic structure where we can see the yttrium atoms, then we are seeing the copper ones, barium in between, and then the oxygen. So these are the conduction layers, and the 1, 2, 3 superconductors form as layers of copper and oxygen atoms which are sandwiched between the layers that are containing the other elements or compounds. So majority of high temperature superconductors are ceramic metals. On the other hand, metallic superconductors usually work below 73.15 Kelvin, and they are known as low temperature superconductors. Metallic superconductors are also called ordinary superconductors. Advantages of high temperature superconductors is that they can bear high critical temperature, so they have strong properties compared to the lower ones. Several high temperature superconducting devices are used for magnetic resonance imaging, magnetic leviation trains, etc. Josephine junctions, which give a very good continuous flow of current. High temperature superconductivity is also a technology that facilitates the use of ceramic metals for conducting and transmitting electricity with little or no resistance loss. All high temperature superconductors, yes, do require a cooling system, and many other compounds are also used as high temperature superconductors, but they do require cooling system along with it. The properties and uses of superconductors. The biggest property of superconductor is the resistivity is below the critical temperature. Magnetic flux is expelled from the superconductor and it starts behaving as a diamagnet. Superconducting state is destroyed by large magnetic fields and large currents. Transition temperature varies with isotopic mass. Few common applications of superconductors are superconducting quantum interference device, SQUIDs, which are capable of detecting very small magnetic fields, and hence they are used as diagnostic tools in detecting brain signals. Magnetic leviation. When a magnet is brought near a superconducting coil, the current is induced in the superconductor, which in turn produces magnetic field. The magnet can thus be used to make float in air on the superconducting coil. This is known as magnetic leviation, which is used in maglev trains. Superconducting magnets are used as they carry large current. Superconducting coils make possible the use of magnetic resonance imaging machines used by doctors to examine soft tissues inside patient. Superconducting grids are replacing the aluminum grids because they can be built by using superconductors. Magnetic resonance imaging in medical field or the MRI scans is a process which is used by doctors to check what is going on inside the human body. The use of superconductors has made this procedure far better compared to the conventional magnets which were used. So the common ones are the maglev trains, squids, electronic chips, etc., medical facility, magnetic resonance imaging, particle accelerator magnets, power lines, electric motor, generator, transformer, etc., which are using superconducting magnets in them for their use. So it is a very good advancement in technology with superconducting devices. Few practice and common questions can be: what is superconductivity? What is transition temperature? What do you mean by Meissner effect? Write a short note on high temperature superconductivity. Define type 1 and type 2 superconductors. Discuss in detail the applications of superconductivity. So superconductivity is the phenomena where a metal or behaves as superconductor below a certain temperature. Meissner effect is the property of expulsion of magnetic field. Critical temperature is the temperature at which the material undergoes a transition from normal state to superconducting state. Same thing holds for critical magnetic field. Type 1 superconductors are the soft ones having single magnetic field used in small elements. Type 2 are the hard ones having two critical magnetic fields, having a mixed state, and have a wider range of usage. The Josephson effect is when two superconductors are combined with a thin insulating layer kept in between them, electric current starts flowing. Squid superconducting quantum interference device is a sensitive magnetometer used to measure small magnetic fields. The amount of magnetic field penetrated by the superconductor is known as London penetration depth. Thank you.